All right, now we're going to talk about tessellations. Now, tessellations are the repeating patterns. And if you are in my room while you're listening to this video, I want you to look at the chalkboard that's underneath the pi symbol, underneath the number line. If you see all the postcards by M.C. Escher, he was the king of tessellations and using color and things to make things work. He was absolutely phenomenal at it, and it's a repeating of a pattern. And so we're going to use tessellations. Now understand, I don't ask tons of questions on this on your test. I do ask a couple, but it's more like, does it have certain types of it? Don't worry about it. Like if this is not perfect, it takes a little bit of time to understand. This is not one of those life and death lessons, but they're good to know. The first thing is a pattern has tessellation symmetries. Excuse me, I said that the wrong way. I have a bad cold. And I totally said the wrong word. Translation symmetry, please forgive me, if it can be translated along a vector and the image coincides with the pre-image. Let me explain what I mean by this. Do you guys see these birds and this wallpaper pattern? It's really kind of an ugly wallpaper pattern. But you notice how this one can be translated if I just take a vector going this direction onto itself? And then you notice how this one can go onto itself. And you know, it just repeats the pattern. Well, that's translation symmetry. The symmetry is still there because all I have to do is translate it and it gets a new one. There's also what's called a frise pattern. A frise pattern is just the symmetry along a line, so you can just totally see that it's being repeated. So that's a frise pattern. So it's just so you know that. It's just a fun term. Both of these down below are actually frise patterns. They can repeat on the line. But we also have what's called glide reflection symmetry. Now, this would also be like a translation reflection symmetry, so it's the same type of idea. With that pattern, let me just put in the word again here, reflection symmetry. Let me tell you what I mean. The first one does not have glide reflection symmetry. What glide reflection symmetry is, if you notice, these patterns are exactly the same on the bottom and top, but notice they're off just a little bit. Well, I could reflect this one over and then I translated it. So I reflected and translated, so I did a combination of two transformations in order to get this one. So this one just has translation symmetry, but this one has translation symmetry because I can repeat the pattern over and over again. But this one also has can be reflected because it can be reflected over a line right here, and then it was translated. So this one also has the glide reflection symmetry. Now, looking at these notes, what type of symmetry do you see? Now, this is a pattern. These are like wallpaper borders, kind of boring, but we'll work with it. Notice, does it reflect anywhere? No, but do I completely get the same thing if I just keep translating it over, if I keep sliding it over? Yeah, so this one has translation symmetry. Awesome. Now, the next one is kind of like we got the paw prints. Now, if you look at the paw prints, you will notice that they are being reflected and they're being translated. So like the line of reflection would be about like right here. Well, it's hard to show because these would moved, but if you move these back, they'd be reflected over and they would be sliding. So first of all, you can see that's repeated. So you have your translation symmetry, which I think is the easiest one to see. And you also have your glide reflection symmetry. So it's just a telling of the pattern because it's the same thing, it just kind of got reflected at an angle. All right, let's look at the next one. It says, identify the symmetry in each frise pattern. Okay, the frise pattern just means repetitive translation, so don't worry about that. Now, what do I have? Do I have any reflections here? I'm looking to see if things were reflected carefully. I don't see any reflections that I could get, even if I slide things over. But notice, do I have the repeat of the pattern if I keep sliding it over? Yeah. So this one just has only translation symmetry. And the bottom one is actually, please forgive me, easier to see. If you notice, I go right here and I can reflect it over. So that's going to be my reflection part. But can I slide it and repeat the pattern? Yes. So this one, make sure it has translation symmetry because it slides over. And notice if it has In order to have glide reflection, you're going to have translation symmetry. So I do have glide reflection symmetry as well. Because remember, the glide means translation. All right. Now, the next part we're going to be getting here, with my voice cracked too hard, is talking about a tessellation. Now, tessellations are my favorite. Like I told you, they're in my room on postcards. I actually have a bigger book of tessellations that Mr. Lehman gave me, of all people, that shows the patterns, and it's repeating, and it's a real neat way how many of you probably made this in elementary or middle school, where you cut the pattern and you kept it through the whole page. But remember, tessellation is really tiling, and it means you put things together so there's no gaps. So notice here below, when I put them together, all around my point, all of the angles have to add up to be 360, so there's no gaps in my tiling, and you have to make sure your tiling patterns really work. So no matter what, they always have to add up to 360 degrees. Now, quadrilaterals are probably the easiest ones to tessellate with, because we know their angles add up to 360. So if you put the pattern together, even though this isn't a parallelogram or anything that we've had, you can easily see how they repeat because of the 4 different shades. You can see how they can be put together to make a really cool tessellation. But let's just wait here. But I'm going to go to the next page so we can see a little bit more.